Hey, Yuri.
Hey, can you hear me?
Yeah, you sound good. How about me?
All right, yeah.
Yeah, I'm using speaker on my computer because my my Bluetooth earbuds just don't work anymore for calls. I don't know why, but they are really uncertain in terms of the quality on phone calls. So anyway, you might hear my birds. I think Suji, he's either going to be late or he won't make it because he's got a meeting that's running over.
I think he wrote something about joining. Let me see.
Yeah, he did yesterday, but just now he directly.
Oh, okay.
Yeah,
Okay.
he directly said he's in a
All
meeting.
right. Yeah, I see.
Running. Yeah. If that happens more than once, we can, we can always change the meeting. So maybe I'm sure he knows that. But with the three of us, it's kind of nice to have all three of us on the call. So, did you go to St. Petersburg?
No. I went to Spain and France.
Was that family or was it?
No. France it was like we were thinking of doing this vacation for a long time, and it was an opportunity. Like basically, we had time, and we didn't have any obligation in August. And normally we don't vacation in August, but this year it was all like we couldn't go in June. We usually go in June, so yeah. So we did this crazy trip. A little bit. It's not crazy, but like we basically did like a loop around Pyrenees. So we flew in and out of Barcelona, and then basically we're in Catalonia, went to France, stayed on the Mediterranean coast, and crossed over to Atlantic coast to Basque country. First French and then Spanish, like San Sebastian,
Yep.
Bilbao, and then went back to Barcelona, and then we have friends in Paris, so we actually flew to Paris for 4 days.
Yeah. Nice. Yeah. It's basically you covered the part of Spain that I haven't covered at all. I've only been Barcelona and South. So was it hot?
Oh no, it was really nice. We lucked out. It wasn't raining, so actually it was hot. I think a few weeks before we got there, but then overall it was pretty mild. We actually also went to from Paris. We went to Belgium, just because our friends wanted to go. So there it was almost chilly, but I took a jacket with me. I never put a jacket on, so the whole trip. So.
Sounds perfect. Yeah. And the COVID situation was reasonable for you guys?
Yeah. We bought a ticket basically like a week before because I was monitoring, and the cases were going down. So yeah, we never ate inside. But like in San Sebastian, we were supposed to go. That's amazing food because they have amazing food as it is, but also I think they have like more Michelin restaurants than any other city. So we actually we had some reservations, and the restaurant closed for 10 days because somebody tested positive. So
Hmm.
I still haven't been to a Michelin restaurant.
I don't think I have either. Maybe in Portland. I don't know. That's cool. It sounds like you had a reasonably nice trip.
Yeah. And then what happened is when we were there, basically, US cases are going up now, and also US is not letting Europeans in. So they said, screw it, we're not letting Americans in. So they basically changed their guidelines. US on the like basically list of like countries to try to avoid. But it's a recommendation, so every country is doing it on their own. So some countries don't let Americans in anymore. For some don't let unvaccinated people in. Like if you're vaccinated, you have to like test.
Yeah.
So it's much more difficult.
Yeah. You had the whole continent to yourself. You guys are the only Americans.
No. People there were quite a lot, but we were also in places where Americans normally go to, because we went to in France. We basically went to French where French people go for vacations. Yeah, and also like France doesn't let many people in, so normally you get a lot of people like, from other countries. Like nobody from Russia was there because Russian vaccine is not recognized by EU and vice versa. So nobody from Russia who only had local Sputnik can go to France, for example.
Right.
So,
Okay. Who just
all right,
joined?
I think we have oh, we have Mayank. Mayank.
Yep. Hi.
Hi, you guys know each other?
Oh yeah. Mayank, he led a bunch of classes in TWIML. You probably
Sweet.
were in some of them.
Yep. Usually we also have Sujit on here, Mayank, and so usually it's just me, Sujit, and Yuri, and sometimes we have a visitor now and then. So we haven't really started discussing any NLP or embeddings or anything yet, but did you have something you were sort of interested in, or just want to?
No, I wanted to learn what you guys were having today. So I did not have anything particular in mind right now. I joined in to get an overview of what you guys are currently discussing. So
Well, we could give you a little summary and just in general, sort of the types of things we cover. And there's certain, I think, sort of centers of excellence and experience we have, or centers of experience that we tend to touch back on. And I'll give you a brief summary if you want, and then Yuri can straighten me out. Does that sound all right?
yeah.
So in case you want to come back another time where you have a question in those areas, it's a good place for them. One of them, vector search. We talk about search. Sujit's quite a search expert. He's been in the search world for a while. And so we tend to talk about, cutting edge stuff or fairly cutting edge stuff in search, such as vector search. And I've actually sort of demoed a tool called Pinecone, and I'm hoping to do a POC over the next year with Pinecone, which is a vector search database, but it's a vector search engine. We talk about other things in search as well. Now we've also, and all of that, of course, goes with embeddings, and we talk about sentence encoders a lot, and clustering sometimes. I personally, I've done at work, I'm working on a Word2Vec project for similarity search, for semantic similarity and document similarity, and use some other similarity search stuff and similarity engines. I'm also a taxonomist, so we don't talk about that too much. And also talk about entities and ontologies, in particular though, entity linking, entity recognition. Sometimes we talk about Spacey or the Stanford library, keyword extraction. Yuri, keep me going. What else are sort of our things we tend to talk about, discuss, and play with on this call?
Yeah, a lot of like kind of small NLP projects that we're doing also. Like we all kind of work on like different stuff. So this is a place to kind of try to like show. I think my main kind of reason for this, like there are very few, like, basically, and I think for maybe for other people also, but at work, not many people are working on NLP. So if I'm doing something, I really don't have many people to discuss it with. So here I can actually like try to show some projects and get feedback that's maybe not more valuable without showing anything proprietary or any, so I tend to work on I work on sort of ontology matching project. That's one of my big projects. And the other, then I do small NLP sort of entity recognition type of projects. We have knowledge base that we have, and we building stuff on top of that. So I'm trying to like do different projects. and then also we work on search. I don't do search myself, but I'm kind of helping with some aspects of search, vector
Nice.
search in particular. And also
So
we kind
you,
of exchange. We a lot of times we actually like exchange of a lot of like non-work stuff
Mhm.
that we see, we participate in. Yeah.
So you guys have a lot of overlap with respect to the different aspects of the NLP and embedding world. And do you guys also discuss Hugging Face or Transformers too? Because Transformers are
Oh yeah, no, yeah, it comes up all the time because I'm using one of the networks I'm using for my like matching sentence similarity is sentence bird, which
mhm.
is actually like built on Hugging Face, and actually main engineer just moved to Hugging Face that built it. So
Yeah, and you can use most of those models in through Hugging Face now, I think. Not all of them, but
oh no, they were always built like they were always like I think from scratch they were built with Hugging Face.
okay.
Yeah.
Yeah. Hugging Face in the NLP world is right now the most coolest company to work with.
For sure. So, Mike,
Uh,
have you heard of the new their Auto ML product built on top of their stuff? Have you seen anything on that yet?
no, I still haven't got the time to go over the things from AutoML of the Hugging Face yet, but yeah, I would much like to.
Yeah, so like I've used we're a GCP shop. I work for Tech Target, they're a publisher or sort of a marketing martech organization. But in that job, I I try to solve a classification problem using Vertex. GCP has a auto
Okay.
ML, they renamed it about 5 months ago, all their AI auto ML stuff, the Vertex. So I
Mm-hmm.
a little bit of experience in there using their auto ML platform. That was interesting. And I shared that on here, but I'm also interested in the Hugging Face one. I really need to try it out. But yeah, I mean, that's way high up, but a lot of times so we're very practically focused, but we also cover papers sometimes to some degree. But we're always sort of, to a large extent, focused on work and bringing new things into work, stuff like that. But
Yeah, I have also experimented with Vertex, and that's cool. I have experimented with the auto ML features of Keras, uh, but not with the Hugging Faces.
yeah, I mean, auto ML for NLP is a secondary sort of thing, right? Like auto ML for tabular data came about quite a few years ago, well, a couple of years ago, really, in the public eye. And so it seems like now NLP is beginning to mature in that area. What is your background? I guess I haven't, I don't really know what, like, who do you work for or work with, that kind of stuff. What are your main areas of focus in NLP and so forth? If you don't mind sharing.
Um, yeah, basically in NLP world, I'm not much of a guy here, there. Uh, I basically work with vision stuff more and more of a general uh, low level, you can say, vision with 3D camera or iPhone's camera, or more of the simple vision with your diffusion, radiance fields, and representation learning stuff, and then graph stuff. So I'm much more focused on those areas. But in the NLP world, I am not much of a expert here, so I came in to learn from you guys and see what's up in which parts of the uh, uh, world in specifically here. So yeah.
Yeah, we also do graph, talk about graph. I tried out Sage Graph and a couple of their demos and worked through, the library a little bit. That was interesting. So, we do talk about graphs as well. Funny thing, the only thing I don't have much to share this week. The only thing I sort of had to share was not really directly NLP, though I want to bend it in that direction, which is outlier detection. And so I started. Have you guys heard of PyOD? Yeah, PyOD, PYOD. That's a library, a Python library for outlier detection.
Oh no.
Yeah,
No.
let me paste it here. Evidently, let me see what this is. Evidently, there's not a lot of Python stuff for outlier detection, but it's becoming more available. It's more of an R thing, I guess, because it's so statistical in its origins. Let me see if I can get the URL in here. Oops. PyOD. Well, anyway, this is the name of it. Is PYOD. Okay. And I ran through a tutorial on it. And let me see if I can get, here's the docs. So, I mean, I can run through the notebook I did. It's very rough, didn't have much time, but I can run through the notebook of the tutorial I did and show a very rough overview of the library if you guys want. I mean, the reason I started looking at outlier detection is because I'd like to be able to get I don't know, maybe Mike, you might have some ideas about this. We talked about it last week, but I don't even think there's much in the literature on it. But when you do it, I do a similarity search, concept search, and I get back a bunch of documents. Okay. Now I need a threshold. Right now I set an arbitrary threshold, but I'd like and have a human reset it, but I'd like to automate threshold setting, at least to get you close. And so I was thinking about distributions. These are documents, right, coming back from a search. So how do you automatically set a threshold below which you throw the documents out, above which you keep them? Because
so I would, yeah, I was out last week, and I don't think there were any notes, or usually like chat kind of good indication of what was discussed. But why not? So I'm also have I have a threshold, but why not just use distance?
Yeah, and that's, first of all, there is a library. HDB scan does have actually an outlier detection, I think, that does that. And also the PyOD, like the demo at least, is the KNN, right? And so you basically can get, it's you cosine or Euclidean distances, right? That's what it's based on. Is that what you're talking about?
Yeah. So when we do like our matching, we just basically we pick some threshold and saying like things that are within this distance, that those are good matches, and everything else is garbage. So just throw it out.
Within the distance to what? To each other?
Oh, like yeah. So so if you say it's similarity, yeah, it's just a cosine similarity. Or
so just the documents that are more dissimilar in general.
Yeah.
Yeah, that's exactly what PyOD does in this example too. And they also have like 10 other algorithms that you can use. So it's one of those sort of libraries that allows you to play around and try all sorts of outlier detection algorithms. Have you actually done that before, Yuri? What's the product use case there, or the business use case? What are you?
Oh, It's not even. It's actually not outlier detection for us. For us, it's just basically with similarity, you want to keep good results and separate it from weak predictions. It's just you know.
Is that is that in your search engine or something, or more of a classification problem or something?
Yeah, in mapping, right? You
Okay.
just want to but I want to say like so for outlier detection. So were you in so last year there was a class there was ML and TensorFlow class. I'm really bad with names. But yeah, there is the book that we were reading that was scikit-learn and then TensorFlow. And the scikit-learn part, they had like a big chapter on outlier detection, I think, and I might be confused. I need to go back and see because I think that's where I saw outlier detection last time.
Yeah, so PyOD is built on top of scikit-learn, so
Okay.
it's probably using all of that. But yeah.
Yep, I just checked out the documentation, and it has implemented a variety of algorithms for the outlier ensembles and detector combination frameworks that it has.
Yeah, it's got a bunch.
Yeah, bunch of.
I got a question. I mean, this might be odd to what I was reading, but about the outlier detection is there seem to be actually three types in a sense. There's, which I didn't quite understand. There's unsupervised, supervised, and supervised. Now I know what those three things are, but it was interesting. The unsupervised, at least with the KNN, was, basically you don't really train anything. You just put everything into a similarity space, right? You don't have any Y hat. You don't have any answers. It's just unsupervised.
Yep.
That. And when you do the unsupervised, you want to have data that it has to be data that has outliers, right? And but what they say is when semi-supervised, and I didn't see exactly how to do that, is when you have data where you don't have outliers to provide to the model. So I think you still don't have a truth, but you're just putting it in there, and because you want to hopefully, then what you do is training is just putting your stuff into your cosine, into your space, your vector space, whatever, probably a KNN similarity space or whatever. And both the unsupervised and the semi-supervised, but in the semi-supervised, somehow it can see if there's something that's an outlier, even if you've only fed it normal, even if the space has only been pre-calculated for normal. I mean, it seems reasonable. But then supervised, I don't know what that is. Do you guys have any experience with outlier that would explain those three types of outlier prediction models? Maybe it's a weird way to think about it. It was just in that article I read.
I really need to remember because I think it was a year ago when I looked at it last time.
Why were you looking at outlier detection? Was there another use case other than the one you explained?
It's actually, it was really interesting. So it wasn't a problem I'm trying to solve. It was a problem that a friend of mine was trying to solve, where it was basically a financial market problem, where you you want to like use all the data that you have, but in stock market data, quite often you just get like, sometimes you get like bad results. Just because of errors, you get really strange signals, and you really want to remove them from your algorithms. Like basically, you want to do outlier detections on them because it like can throw your predictions quite off. And I think and I'm trying to remember now. So I think the the idea was that they had really fancy algorithm that was, doing predictions. But in order for this algorithm to work, you wanted to remove outliers with another algorithm before. So I was trying to help him to kind of build a separate outlier detection. But now I have to go back and look.
Yeah. I mean, I came across that kind of a use case quite a bit, where you sort of use outlier detection for EDA, and then so that you don't skew all your results with the outliers, your statistical analysis with your outliers.
Yeah.
So it sounds like that use case. And in general,
semi-supervised, yeah.
Yeah, I'm not sure if that applies to NLP, possibly that use case, but it's always interesting to see outliers when you start looking at your data. What were you going to say about semi-supervised?
Yeah, there is a XG board in the pyd.models package. There is a XGBOD module that deals with the semi-supervised method of outlier or detection, which uses XGBoost as a classifier, which is applied to the augmented features which we get from the unsupervised outlier detector. That is what they have given here is that XGBoard is a class for outlier detection, which first uses the past in unsupervised outlier detectors to extract richer representations of the data, and then concatenates the newly generated features to the original feature for constructing the augmented feature space. So, and this semi-supervised method based on a pre-labeled ground truth. They do this. So that's the semi-supervised. The completely unsupervised will be the automatic classification based on the patterns that representations that it has, and completely supervised might be, I think so, the ground truth labeling that has been done by hand, and it requires some sort of classification mechanism, or some maybe here, I don't know if some sort of a deep kernels can be enabled, like RBF, or some sort of kernels can also be used other than the PYOD modules for bringing in those supervised classifications together to form a rich boundary.
Well, I sort of get it. I get you use a unsupervised method to generate features. I don't know if this is for documents or for the data. It's for structured data, or both. I guess it's extra. Yeah.
Yeah.
And then it gets those features and it creates a decision tree, or XGBoost kind of trees, right? And turns it into a classifier problem. Is that sort of what it's doing, you think?
Yep.
It's kind of
Yeah, exactly. It's exactly what it's doing.
I came across an interesting one, autoencoders for outlier detection. I did not fully understand it. I tried, but you go from whatever your dimensions are, you then reduce, and then you increase back up to the same dimensions, and to try to recreate. And so I guess it's if it has a harder time recreating it, right? The vector. Like if you start at 400, it ends up at 400, and if the difference is just too great, I forget the name for that, perplexity maybe or something. If it's got high perplexity or whatever, then it's more likely to be an anomaly. So I did come across that in a couple places. I don't quite intuitively fully understand it, except for that maybe the vocabulary. This is sort of an NLP example for sure, except for that maybe the vocabulary is out of the norm, sort of. So have you guys ever heard of autoencoders for outlier detection, particularly in NLP?
No, but I'm looking at the basically on the same page that I posted was the documentation, was the one that Mank was talking about. Like it's on the top of that page.
Oh, they
Yeah,
have
I'm just
encoder.
yeah.
I haven't gotten that far. That's interesting.
Yeah, it's I don't know how to.
I'm-
I don't know how to link to the middle of the page. Oh yeah, there is a.
Yeah, I see it. No, I see it. There's anchors. Yeah.
Yeah.
Yeah, it's the auto_encoder model, right? Interesting. Yeah, I was thinking, of course, I guess one last thing is I was thinking, outlier detection in NLP. You know how you can use topic modeling. We've done much if you can use topic modeling to monitor, websites or document collections over time and see how the topics are evolving and so forth. It'd be interesting to add along with that a document outlier detector, so you could find stuff that's different than the others. Like at my particular use case, we get vendors, software vendors. We get activity from our customers that are software vendors. We get their pages, and I did set up an auto classifier for that. But also, it would be interesting, and also content typing. It'd be interesting if we took monitor all the product pages and find one that when it's an outlier, either to their industry or which is a group of vendors product pages or to their own. That might be an interesting use of outlier detection for NLP. So I think there's something. Yeah.
What is that? Was that the original use case while you're looking at it, or was there something else?
Well, the original use case was for auto threshold setting.
Okay.
Yeah. But then that one, I realized that's what I came up with, because I actually started searching on NLP and outlier detection, came across the autoencoder, and I think the autoencoder example, they said something similar to that, just to find like interesting movies or, just ones that are different, So like I've watched so many movies, I like completely strange, different ones, right? So I could understand that, or something with an NLP that's very different than everything else. I could see using that for generating ideas, or for, in a research area as well, monitoring new ideas that are very novel and so forth. So I was just curious to try to take the outlier detection stuff, which isn't used in NLP very often, and try to apply it there. So I think those are the two use cases that I have so far. So, all right, is there anything anyone else wants to say on outlier detection?
No, but it's a really interesting library. I now want to go back and look at the non-NLP, like it was a time series problem.
Yep.
Yeah.
Cool. I really love these libraries that make just in a way, Hugging Face is like that, right? They make a ton of different variations on the solutions to the variation on the problem available, right? So Hugging Face, you just use every model. That thing's so foundational. But there's a couple of these that are, I think Sage, no, I think there was one with graphs that I used. Remember that one? I think it might be called Sage Graph. I don't know, but I know Sage Graph is the algorithm, but it had like 10 different embeddings. So it was like a graph embedding library that had like 10 different ways of doing embeddings, just like this one. I can't remember the name of it now, but anyway, I love those libraries. They're not abstractions, they're aggregations that give you a lot of power.
What's the library name, Darren?
I'll look it up if you want while we're
okay.
We're doing this. Let me see. I have it.
Yeah, sorry, I just joined. My previous one was running over. I just finished.
Oh, hey, Suji. How's it going, man?
Sorry. Yeah, all right. I'm good.
Yeah, we also have Mayank on this call.
Hey, Mike.
Hey.
Hey.
Oh, you know what that graph library was, Sujit. I talked about it a while ago. But what we've been talking about though was PyOD, because we talked about outliers, you and me last time, right?
Yeah, right, yeah.
Outlier detection. So I found this library you may be aware of called PyOD.
Oh, I haven't. Yeah. Okay. All right.
Do you see the links in the chat, or you don't because you just
Let me. Yeah, I do see it now. Yeah.
okay. Yeah, and it provides access to a number of different outlier detection methods. A great.
I haven't seen this. Okay, cool. This is nice.
Yeah. And also, I came across an interesting use case. I don't know if you're that, but we're using autoencoders, but where you're trying to find novel content. So it's kind of an interesting NLP application
Okay.
of outlier detection. You're trying to find the document that seems different. So that's a case where outlier detection is a good thing.
Right, yeah.
And maybe.
Oh, I see this. Yeah, I remembered the use case now. Okay, good. Okay.
Yeah. The use case I had to start with last week was the threshold setting. I was trying to auto threshold set and
right.
result set.
Right. Yeah.
But I think we've kind of worn out the outlier detection discussion. Does anyone have anything else on that?
No.
Okay, so who would like to bring anything up, talk about anything, ask any questions, talk about something they've read or anything's going on? Does anyone have anything?
I can show you the result of my Dev 10. I trained the clip model on image clef, so yeah, I have a screenlit demo. Yeah.
Is this the one where you are going from your competition? Now you're using the images instead of satellite images. You're using imaging, healthcare stuff.
Yeah.
Okay. Yeah, that would be cool. That clip stuff's pretty awesome.
Right. Do you want to see it? I can do it now, or we can do it later after everybody else.
Always want to see anything in Streamlit you have.
Okay, cool. All right.
Loves.
So here's my, okay, let me share. So we'll go top down, right? So, okay. So I was showing this to my boss earlier today, so I still have it up. So this is, so basically it's the same thing that we did with the satellite images, MindQ, all this. But essentially, this time I used the ImageClef 2017 dataset, which is a dataset used for caption prediction. Not, so I'm kind of reusing that data, right? So it gives you like, I think 180,000 images, 160,000 odd are for training, 10,000 are for validation and 10,000 for testing. So in the data set they gave us, the 10,000 that is for testing doesn't have associated captions. You're supposed to predict it, right? So I basically rearranged things so that, I split the training data set 90-10 into a training and a validation set. And I use the validation set with its captions as my training evaluation set. So for this one though, and I trained a model, and for training the model, I actually got, here is my evaluation results. So again, I tried the same strategy that we did with the clip RSI-CD. So we did, I evaluated against the baseline model, which you just get download from Hugging Face. And at each stage, whenever I created a new model, I measured the same thing. The metric that I used was mean reciprocal rank. So here it is at different Ks, right? So, K 1, 2, 1, 3, 5, 10, and 20 that I used. And as you can see, the baseline is about 43%. And
so, Sujit, the Ks are just position?
Yes, the top K, right? So K1 means the first position only. The K1 to 3, or K3 means 1, 2, and 3 positions returned.
Yeah, it's kind of interesting to see those 8s to the right of run 1 and 2. Anyway.
What does that mean? Is it like the word is in the caption? Or?
So essentially what I'm saying here, so when you train clip, right? You train it with a bunch of images, like a sequence of images and a sequence of captions, right? So that's your input. So when you evaluate it, what I'm saying is that, my labels are along the diagonal, right? So for my first image, the caption that should match best is the first one. For my second image, the caption that should match best is the second one, and so forth, right? So along the diagonal. So basically, I'm saying that, in the top K results for this particular image that I've got, let me show me the top three, the more high top three by probability, right? And then within that is the diagonal caption among that, right? And if so, what is its position? So in case of K equals 1, it is either in or out, right? So that's, but in K equals 3, if it's in position 1, I give it a 1. If it's in position 2, I give it a half. If it's in position 3, I give it a 1/3. And then I take the average.
Okay.
Right?
Oh, I get it. I
So-
missed the position.
Yeah.
You're not judging the ranked results. You're judging each individual. I get it.
Yes, and then I'm averaging it over the whole 10,000 data elements that I've used, right? Against the
How
entire
many-
captions.
So it's fixed number of classes that were captures?
No, there is no fixed number of classes. There is no classes here. So essentially, I'm saying that,
If it should be in position 1, was it in position 1? No,
exactly,
in
exactly.
position 3, so I discount it. If it should be in position 5 of the rank results, this image for this particular query, then is that right? Then if it's in position 5, it gets a high score, or
So my
it's only
expect-
1. I'm sorry, it's only 1, right?
yeah, expectation is that it should
Matching
always
the
be in position 1, but
Yeah.
if not, I'm looking at the top K positions, and depending on where it is in the top K positions, I'm going to give it a rank, which is 1
Yeah.
over the rank, the position, basically.
Yeah, let me ask you something real quick. This is
Right.
basic, I think you answered before, but when you train the model, the fundamental idea of the PIP model is you training pairs of image
Yes.
with caption, image with
Yes.
caption. So you end up with this vector space that has images and captions together.
Mhm. Yeah,
And now you're going back and you're looking at those image caption pairs.
exactly.
And you're saying, did it show up at 1? If it didn't, still showed up, that's kind of good. I get it. Cool.
Right, right, okay. And so in the clip RSI-CD, I didn't actually use MRR at K. I used more like a recall at K kind of thing. Does it appear within the top K or does it not appear? So this is a little tighter in the sense that it will, depress the scores faster. So, but even otherwise, the medical data set is harder, it seems, right? So, the untrained model did not do very well, but when I trained it, it did start doing better. One other thing I did was I actually did not use any image augmentation or caption augmentation that we used in RSI-CD. However, because we had so many training images, I used a different form of regularization. I tried sampling, right? So the last model is basically does a sampling of 50,000 images out of the 140,000, right? So you can see it here. So this is another new thing that I've started using. So all of my runs have their, all the properties enumerated in a YAML file, right? So here I'm saying, give my train sample size is 50,000 and batch size and validation size and whatnot, right? So, and my learning rate, so all my parameters are stored here.
Hey, what tool are you using for that? Are you using a tool or just
No, YAML, just hand.
Just YAML.
Yeah,
Okay.
Yeah.
So you're not using weights and biases or
No,
anything
no.
like that? Yeah.
I cannot use weights and biases from within my company because of
Yeah,
security issues. Yeah. So
Yeah. But ML flow isn't. But anyway, you don't need it. That's fine.
yeah. So any case, so this is what I got, and this is my demo. So we'll skip. Okay, this is from my best model. This is the training loop, right? So it looks like it's kind of flattening out here. So I don't think I can get very much better than what I got here, but this is what I have. And so back to the Streamlit demo. So I have I am able to use this train model to do text to image search, because it's a single embedding space, right? And an image to image search, which is basically image similarity, right?
Hey, Suji, sorry. Not that it matters, but TEST, it's TEXT.
Oh yeah, thank you. Okay,
Yeah,
I'll
yeah,
fix
no.
this. Okay,
No one's gonna care really. And
yeah.
I'm the worst speller in the world, so it's just
Sure.
amazing I got that one. So
But no, it's good. I mean, I'm going to show it to my boss's boss.
yeah.
So, and he might catch it, and I don't like that, Anyway, so one of the things that we can do here is, given a text, retrieve images. So let's say we try some, say, computer tomography. This is basically CAT scans, right? And I can do, so I'm using Vespa to store my, so what I've done here, I've used my trained model to generate vectors for each of my images. And then I have done an L2 norm of them, right? Before I store them in, because I want to use inner product, which is less invasive than cosine similarity, right? More performant. But so I basically want to take care of the norm ahead of time. So using inner product basically gives me a number from 0 to 1, which is cosine similarity, right? Okay, so, and here, since I'm using Vespa supports BM25 based text search. It supports, HNSW based approximate neighbor search. So I'm using all kinds of features that Vespa offers me basically. So here's text search, which is done on the caption alone.
So really fun. So really for CLIP, what you're doing is creating an embedding model.
Yes, exactly.
Embedding space, and then there's nothing on top of CLIP like specific. You're just then using those embeddings in Vespa, which is a vector search.
Exactly, right.
Nice combination of things you've been learning. That's pretty awesome.
Yeah. And so this is a plain, just based on the caption, the text search, and you get, mostly CAT scans, which is nice, right? And this is how you take a CAT scan, apparently, right? So Superman position, apparently. Okay, whatever. Yeah. And so then, you can change it to say, vector search, which also gives you CAT scans, but at least in one instance, which I can't find anymore. Maybe my code improved or something, but it showed me something other than CAT scans, which looks very similar to CAT scans though. And one thing you can see here says, this caption is now CT scan, right? But yet it found it because, it's looking at the image encoding, right? So CT scan is also computer tomography.
Okay, I got a question. For you now. So all three of these, search, vector, and then the combined search, are all using Vespa. What is the text search in Vespa? Is that just
it's against the caption text? I'm using BM25. So Vespa supports both. It's a hybrid search engine. It supports BM25. It supports the HNSW approximate nearest neighbor search.
So the vector search is the ANN.
Yes.
And the text search is more the traditional search.
Right, BM25 based.
Okay, and then you combine the two. That's interesting.
Yeah, you can also combine it, and it's actually really simple. Let me show you.
So the text search, basically the vector search really is image search.
Right.
But you're using text.
I'm using the caption text for the text search.
I mean, but you're doing computed tomography and you're searching. I get
Yes. Oh, I see, the vector search. Yes. So I'm taking the vector of computer tomography, right? And I'm matching it against the image vectors in the corpus.
Yeah, no, I get that. But then with the text one, you're just doing text too. But I thought part of the whole thing was you could then find images that don't have captions. But you couldn't do that with the text search. You have.
Yeah, for those which don't have captions, I will not be able to do it with the text search. I will not find them. Right.
But you could search text and then do a vector search and get the images.
Yes.
Okay.
I could actually do a vector search pure on, say, computer tomography and get images of computer tomography which don't have captions.
Yeah. So, but what I'm wondering, so you must not have the use case at work with images with no captions. I mean, because that's one of the beauties of the CLIP model, is it bootstraps you into a situation where you can search using text to find images that haven't been captioned, and also beyond the caption language, because caption language can be very inconsistent and short. So you may want. I don't know if that's an important use case at your work, but
it is and it is not. It is a use case that we have considered, caption prediction, where given an image, it will suggest an appropriate caption for you. This is for authoring. So it's support for authoring tools, right? So they upload an image and we can basically generate a caption based on what they have uploaded. It is not super important for us, but it is a good, useful feature that we want to give at some point. But in this particular corpus, because I'm also using the test images, the 10,000 test images without the caption, it is possible that I will see no caption provided, right? Records that will come up on vector search.
Yeah, I mean, it's just the superpower of clip that you're not demonstrating here. But
yes, true. Yeah.
I'm with you.
Yeah.
So, sorry, please continue.
And combined search is basically just you can sum them up in different combinations. So essentially, it's as simple as, let me show you what it looks like in Vespa.
I'm curious too about one thing, which is recall. So you're kind of looking at precision, right? And comparing the text versus the vector search.
Mm-hmm. Yeah.
And you can see, like with all similarity engines, it gets more relatedness in the vector version. But it would be interesting to know with recall, because the idea is, the language is much thinner. So maybe vector search would produce a lot more. I mean, you need a threshold, of course.
Right. Yeah. Yeah, I'm just pulling the top 10 here, but I could obviously pull much more, right? So what I was talking about, the rank profile, right? It's as simple as providing something like this. So for the text search, this is the caption search profile that I've got. It just says BM25 of the caption text, and caption text is declared here, right? This is summary, which means provided in the output, and index says that index it using BM25. And it's enable BM25. I think you can also enable TF-IDF. I haven't tried it though. So essentially, the rank profile is basically, you say BM25 of caption text. That is the relevance score that you will get. Similarly, for the vector search, it's closeness, which is a proxy for inner product, and essentially it's cosine similarity, because we are L2 norming our vectors before we put it in, and also we are L2 norming it when we generate the query as well. So that's another. The rank profile for the combined one is just the sum of this. I can also put in different combinations, right? So I can say 0.5 of BM25 of caption text plus 1.5 of closeness or whatever, right? So I can do that as well. But for simplicity here, I've just taken the sum. And so when you look at the caption search for that, you'll find that they're largely similar to the text search, mainly because if you look at the scores, right? So you'll find that the relevance is in the 1 to 5 range, right? Unfortunately, it's not standard. I mean, with different query terms, it changes. So it's hard to kind of figure out a standard to score it appropriately. But again, I mean, that's once, if this goes into production, then then we'll start worrying about that, right? Depending on
how do you solve that problem in general? Because anytime you use search engines, you run into that, which means you can't set somewhere like a threshold.
Right. Yeah. So maybe something like a dynamic threshold, perhaps. I don't know. I mean, so we could spend a few more cycles and say, okay, restrict the threshold by some weight, or compute a weight based on what we get in the top 10, and redo it, something like that. I haven't figured out exactly how, but it will probably involve more cycles to do, right? So yeah. And for image to image search, yeah, you have to copy, and so you have to provide an image ID from within the corpus. There is obviously the other way to do it, where you can import it from the internet, upload an image from the internet or something. But I haven't done that because that's not really a use case for us, at least right now. If they ask for it, I will. So essentially, you put in the image ID, and the image only is basically, it takes the vector from the image and does a cosine similarity with using the HNSW index, and you get back results. And similarly, since I'm picking up from the corpus itself, I can do image plus text, where I take the image vector and the caption text, and I do a combined search, like the one here, right? This guy. right? So, and that gives me a slightly different. So basically I've provided bunch of different kinds of search, and, it can be conservative, as, you can tune it, based on how conservative you want it. You could use different strategies, and you could even do a two-step thing where, if you want to go super conservative, take the top result from the text search and then find images similar to that, right? With the caption text enabled. So you will never get unexpected images, right? If you want to be like super careful about not showing unexpected images, which is a concern for us. So there are different strategies, and there I think that's my demo. Yeah, so I'm going to stop sharing.
So I have two questions.
Sure.
First of all, that language with curly brackets, that's a Vesper internal language, or like a config files?
Oh, that one, yeah, it's just a YAML thing that I've, it's kind of, I created it for myself. Basically what I do here, okay, let me show you this. So in my train, so if I go to my source.
Dude, I was thinking that was a standard Vespa schema or config.
Oh, the schema file. Yes, that is a standard Vespa schema. Yes.
Okay.
Yeah. Sorry, I misunderstood your question.
Like Solar, I'm like.
Yes, exactly. Yeah. In fact, Vespa has a very, I think that's one of the things that kind of might hurt it a little bit in terms of adoption, because the Vespa configuration is very structured. So it's the source main application. It has schemas, right? And for each image type that you have to have an SD file, which basically is the one that you just saw. In addition, you also have to have the hosts and the services, because it's distributed by default. So even if you have like a single thing like mine, you still have to declare nodes, and so there is a kind of a barrier to getting in, right? So here, because I'm using the query vector, I have to declare, not this one, I have to declare what it is. So, so I have to say in this one, I have to basically say that I have a field type called ranking.features.query, and it is of size 512 and so on, right? So I have to do some additional stuff to kind of set up the Vespa. It's actually simpler with Solar because it's just Solar config and schemas, right? Or managed schemas now, yeah.
Okay. And then my second question is, so you have for text search, you just do BM25.
Mm-hmm.
Have you tried using vector search on text? Or it didn't make sense to do it here?
Well, in this case, when I'm, so here, right? So if I do, say, let's do another one, Eosin stain. So when I do text search, right? This is purely, I'm matching Eosin stain against these captions, right? Pathological result, blah, 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 right? And somewhere it says Eosin staining, and that's where it matched. But when I do a vector search, essentially what I'm doing is I'm computing the vector for Eosin stain using the trained clip model, and then, hitting all the image vectors that I have already pre-stored, and getting the best results here.
But it's trained both on text and
it is trained both on text and images. Yes, okay, it's a common embedding space. Yes.
Okay.
And as you can see here, this this is actually going pretty far out. So
So you're showing, but that looks like it's got the staining, right?
It's got the staining, yes.
Yeah.
But
but it's what?
Yeah. Well, I mean, so here maybe it is correct. Maybe this is the staining. I don't know.
Yeah. I mean, the thing that's interesting is you are kind of showing it superpower, because you're showing it return images, not that don't have captions, but whose captions limited language don't cover the angle you're interested in.
Right, exactly. Yeah.
It's a caption for an image. They always have a very specific context in mind, right?
Right.
And because it's an image is worth 1,000 words, whatever, you know what I mean? You always are making serious judgments and limiting your language. So you're basically able, this is great because you could find stuff that was out of the intention of the captioner.
Right, exactly. Yeah.
Very useful. What do you think? What do you think your is your boss technical that you're going to show this to?
My boss's boss?
Or
Yeah,
whoever whoever you're going to.
my boss is very technical. He's more into NLP though, but he was quite pleased with it. And my boss's boss is more of an academic, but he's, academic biosciences kind of thing. So we'll see how that works out.
I see. So you don't really have to think about the business use case so much. They're going to.
Yeah, they are going to basically see if it works out for them. Yeah.
And he's going to be thinking about the mind of the user, your medical.
Yes.
Yes. The practice. This is really with the practitioner in mind.
Mm-hmm. Yeah.
What would one practitioner want to? Yeah, go ahead.
And that's why I'm focusing so much on the conservativeness kind of thing, because doctors are very quick to point out flaws in computer systems. It's I think they kind of fear being replaced, and so anytime they find even a small flaw, they make it a huge thing. So which is why I'm trying to go more conservative, right?
I can find flaws in all of my doctors. You can go to doctors and get 2 different diagnoses, and they're both wrong, and you get cancer the next day. It's cancer.
Yeah.
So screw them. But by the way, so do you have a couple quick use cases of where this would be useful for a practitioner? Like, I'm completely blank there.
It's mostly so they might want to see, right? So at this level, perhaps not, but I'm also limited by the data set that I have. But they might want to see, images of cancerous breast cancer cells, right? Just as a reference, to refresh their memory of what it looks like when they actually refer to one, right? To compare with a real live thing that they're seeing right now.
Yeah, especially if you're not a specialist, right?
Right.
So it could help a generalist decision making in special.
Yeah, exactly.
Perhaps in general.
Yeah, also there are internal uses where my boss gave me some internal uses. Hang on, let me see what I've got them. So I suggested one use case and he suggested a bunch of them. Come on. Yeah. So then I wrote them down somewhere. Oh, here. So image search for internal users to get editorial efficiencies. This is more on the research side. In case we don't, we use just general captions from our publications. Image search for customers. This is the, the application with health and research, if we ever do research. So currently we do caption image search, but using captions and using image tagging, right? So it's a little different. And then these are the captioning of new images, concepts in new images. This goes into the concept prediction and the caption prediction side of the house, and which is the original intent of this data set. And the image decomposition, yeah.
It's not the original intent of CLIP, is it?
No, not CLIP.
So you'd use a different model. Maybe you'd use this vector space or.
Yes, well, the image clef data set that I'm using, right?
Yeah.
So that this data set was meant for caption prediction.
Yeah.
And there is an additional one for concept prediction, which basically, so this is what Arto was talking about. I think for those of you, Mayank knows this. Arto keeps talking about using prediction, so taking this CLIP model and adding a GPT-3 or a GPT-2 to basically take the output of the CLIP model and create sentences for prediction, right? So basically, given an image, it will create this internal representation, which will get passed into GPT-3, which is also trained to understand this encoding, and the output from that would be like a nice caption describing the image, right? So
yeah. So when you say prediction, you mean in the generative sense?
Yes, exactly.
Okay. Yeah.
Does he know how to feed vectors into GPT-2?
I believe so. He hooked up a sequence to sequence.
Okay.
But we never actually got. So that's one of the things we want to take forward. once, so we are being given by the JAX team, they are giving us more TPU time. So one of the things we want to kind of move on is basically this bit where we can predict captions.
Does that mean you're building GPT-2 or 3 model from scratch?
No, all fine tuning. So GPT-3 already knows how to, give an input, it knows how to spout, something, realistic sounding nonsense at this point, right?
Sure.
But we are trying to constrain it so that, it will try to, spout captions, so given an image, it will give you some caption, right? How good or how bad it is not known at this point, but so DALL-E was one nice thing where you give it a text description and it gives you an image, and it seems to work pretty well. I have so the JAX the Hugging Face event. One of the, and actually the first prize winner I think was the DALL-E project, fine-tuned DALL-E project, and it works quite well. I've used some Picasso descriptions, right? So some of his cubist paintings, I've taken that and I created a description of that, and it creates nice images. I mean, yeah, I thought it was quite good.
Right, so I get it. So you're not going to do anything with clip with that. You're just going to follow these, reverse the dial.
Well, clip to some extent, this will be like the clip would be used as an encoder, and the GPT-3 will be used as a decoder in a sequence to sequence. So you can train it end to end, right? Because we have like a lot of firepower at this point with TPUs. So, it makes it feasible to do this kind of thing, basically.
Got it.
So anyway, that is my spiel. Yeah.
Oh, Yuri was asking is, I guess I understand that now. Since you're not feeding a sequence and you're feeding a vector that's got different dimensions than normally your embedding for your sequence would have.
Yes. Well, yes and no. Yeah, you're right. Actually, I mean, how would you do a sequence? You're right. Yeah, we might try to do like break it up like pixel GAN. Basically a sequence of patches and then send it as a sequence. Could be that.
Yeah, especially with GPT-3, I think it kind of takes like actually I don't know, I haven't done it myself yet, but it takes basically standard word-based prompts. So
yes.
Yeah. Have you thought about how entity linking or entity identification, the work you've done with that, how that might relate to this demo you just gave? If you threw that in with clip and you did NER either before processing or
I see. Okay.
after processing, and sort of throw those things together in the mix.
I think it might actually work better.
Yeah, well, not even from a pre-processing, but also from a search and from even just interpreting results or being able to refine results, or maybe, to me, it would be, I mean, it's terrible, but I'd like to have a super multimodal search space in a sense. That's what I've done with my Word2Vec stuff, but of course, it's a little old school. But I want to be able to search on a semantic or or an entity, right? Like a topic,
right? Yeah.
Your ontology, your taxonomy, a keyword from your keyword thesaurus in your language and Elsevier, right? That, right. Those, or an entity, and get back to images, or get back go all directions, with all the different types. So not multimodal usually means text and image, but I'm thinking even broader, right? Like you should be able to have multiple entry points. Like you should be able to enter with a
video or
official
audio
text term, an official ontology topical term, like from your taxonomy, or an official entity term, or maybe free form keywords, like you deal with variety of namings, like synonyms for your terms in your ontology. for a product and get back documents or images, like super back and forth on all the different types. And I'm just, in your context, it's interesting to think about how entities might play a role just because they're so important within your org.
Right. Yeah. Yeah.
Anyway. But that's great. It's so cool to see you evolve and learn new technologies all together, right? You got Streamlit there. You've got your vector search with Vespa, and
yeah, it's a project in 3
crazy.
parts actually. Yeah.
Yeah, I mean, you just keep building. So
Yeah.
nice. All right, guys, we've been going on an hour and 12 minutes. However, we could go another 15 if anyone has anything they want to bring up or discuss or ask or anything at all.
I don't have a lot related to work just because I was not doing anything for 3 weeks. But I wanted to share the event that's happening today. I don't know if you guys seen it. It's called Transformers at Work.
Yes. Were you able to get in there? I think it's
no.
booked.
I saw it.
Okay.
I saw it too late, and they said that they're going to try to stream it live on YouTube, but I don't think that happened. But I registered so they can point me to recordings after that.
Yeah, in case you get that, please share. That'll be
Yeah,
quite interesting.
Tell me what is it? Who's putting it on?
I got it. I saw it.
Sorry, I muted myself. So it's some other company hosting it, but it's mostly Hugging Face, but also other people. I think basic kind of practical things to do in NLP, NLP and search.
Yeah, no, it sounds awesome.
Yeah.
Transform. Totally missed that one.
Yeah, I came up on Twitter's feed today, but
yeah.
Good, thank you. Yeah, I see the page, the link you sent. That's good. Cool.
And then actually, Sujit shared graph.
Yeah, that's actually pretty cool.
Yeah, Graph One Day conference. So it's on next Thursday. So I registered to that. I don't know if I'll attend it live or we'll try to listen to it. But it's basically all the researchers that do GNNs, graph neural networks. They doing state of the art in graph neural networks. That's posted in Graph Channel.
Yeah, and the Twitter for the actual Transformers at Work, I found it in one of my basically Slack messages. So I posted that as well.
Cool. Yeah, that's it for me.
Okay. Just looking up some notes. Oh, there is some sort of conference. Oh, geez, I missed it. Semantics. Oh, that was part of the knowledge. I don't do those though usually, but all right. Great, guys. I guess we'll call it a call and we'll talk next week.
All right. Okay. All right.
Thanks for coming, Mike. Talk to you guys soon.
All right. All right.
Next week. Bye.
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 Thank you.